On this example, we're going to be working a definite integral that's going to require us to work with integration by parts. So as we get going on this, you'll notice it looks a little bit complicated from the beginning, the problem on the left-hand side. So what we want to do is start identifying what our u is going to be and what our dv is going to be. Now in general, we want to use, if we have a natural log involved such as this, let's make that our u. So we have natural log of x is going to become our u. Everything else that's involved with this integral, besides the bounds of integration, are going to become our dv. So dv is going to be the 7x squared and the dx. And it takes a little bit of practice to get comfortable with picking out which pieces are going to go with which of these two things. All right, after we get going on this, we've picked them out. Let's go ahead, and integration by parts requires us both to take a derivative with the u side and take an antiderivative with the dv side. So we're going to find du by taking the derivative of u, you get du. By taking the derivative of natural log of x, we get 1 over x. And we're going to put a dx with that as well. The derivative with respect to x. All right, that's our taking the derivative part. Now we have to take the antiderivative of dv. So that's like 1 dv. We take the antiderivative, we get v. Now we also have to take the antiderivative of the right-hand side as well. So I'm going to bring the 7 along. We're going to use the power rule. So we're going to increase the exponent by 1. It'll go from x to the second power to x to the third power as we increase by 1. Then we divide by that new exponent. Now I'm going to put my dividing right here with my 7. All right, now that we have all the components, let's take those over here and fill in. This is going to equal when we fill into our integration by parts formula. So hopefully my color coding kind of makes sense as we go through this. We're going to replace u with natural log of x. We're going to replace our v with 7/3 x cubed. Now what I'm going to go ahead and do is I'm going to put that 7/3 out in front. But we have the x cubed, it'll go back here. It doesn't really matter which order you put these two in, or if you split them apart and put the 7/3 in front of the natural log, because everything is multiplied together in this component. Now we still have our bounds of integration. They remain the same. It goes from 1 to e, just like our original, minus the integral from, again, 1 to e. That didn't change in this case. Same bounds of integration. Next, let's fill in our v, which is 7/3 x cubed. I'm going to put the 7/3, again, my constants, I like to see them out front, x cubed. And finally, we need to replace du with what we found it over on the left-hand side to be 1 over x dx. Those, again, are being multiplied together. All right, so at this point, let's go ahead. I'm going to just continue down here. I'm going to bring the first part down without filling in our bounds of integration just yet. So 7/3 natural log of x times x cubed, evaluated between 1 and e, minus the 7/3 comes along. Before we integrate, let's go ahead and try to simplify what's on the inside here now. So I'm looking at this x cubed times 1 over x. So that means 3 copies of x in the numerator and 1 copy of x in the denominator. That'll simplify down to x squared. And then our dx can come along again. All right, continuing here, let's go ahead and start filling in our bounds of integration at the beginning. We have our 7/3. It's going to be natural log, and we're going to fill in e for the upper bound first, times e gets filled in for the upper bound again. Then we subtract away as we fill in our lower bound. We have 7/3 natural log of 1 times 1 cubed minus 7/3. We want to take the antiderivative of x to the second power. So again, just like we did earlier, we're going to increase the exponent by 1. So the 2 becomes a 3. Then we want to divide by our new exponent. But instead of dividing, because we already have a fraction in front, I'm going to write that as 1 over 3. Multiplying by 1/3 is equivalent to dividing by 3. Now our bounds of integration go at the end here from 1 to e. And let's think about how can we simplify this down. Well, you may notice that we have natural log with an e on the inside. That's actually pretty nice, that when you compose e with natural log, you get this nice canceling out, and you're going to be left with whatever the exponent is. So in this case, we have 7/3. That natural log of e to the first power becomes 1, and then multiplied by e to the third power. Minus 7/3, but oh look, we have a natural log of 1. Natural log of 1, this component becomes 0. And 1 cubed is 1. But being that we're going to be multiplying that by 0, all of that's going to become 0 on that part. All right, next, let's go ahead and go along here. We have minus. Let's combine our fractions together. We'll multiply numerators and multiply denominators. So it's looking pretty good. And then we still have x to the third power. So I'm kind of thinking about leaving that constant out in front. Now let's evaluate the x cubed at the upper bound. That's going to look like e to the third power minus 1 to the third power. Because remember, you evaluate at the upper bound, then subtract, evaluate at the lower bound. And see if we can simplify this down any further. We're almost done, but we can simplify a little bit. This first part, I'm going to leave it as 7/3 e to the third power, kind of get rid of that 1. I'm going to kind of ignore this part. It's minus 0 or plus 0, doesn't really matter. But let's think about distributing this negative 7/9. So we're going to put a copy with each one of those terms on the inside of our parentheses to clear out our parentheses. So that's going to make it minus 7/9 e to the third power. But then 1 cubed is going to be a positive, 1 in there. So we have negative 7/9 times negative 1 is going to be plus 7/9. Now you may notice that we're going to ignore the 0 in the middle. Doesn't really affect our solution. I think we can get to a little bit better solution if we go ahead and get a common denominator across the board. We're dealing with fractions. We already have 9 and 9 for 2 of our fractions. Let's go ahead and make the first fraction into a 9 for its denominator as well. So to do that, we'll multiply by 3/3. It's like multiplying by 1. And that's going to give us that common denominator of 9. All right, so looking at this, we can multiply numerators. We can say 3 times 7 makes 21. I'm going to go ahead and include the e to the third power up there in that first numerator, ignoring the minus 0. And then minus 7 was already up in the numerator. I'm going to think of that as e to the third power in the numerator. And then finally plus our 7/9. All right, now we can clean this up just a little bit more if we put everything over the common denominator of 9. So that'll give us 21 e to the third minus 7 e to the third plus 7. And you may notice that both of those have e to the thirds. So that kind of makes those just like terms. We can say 21 e to the thirds. We subtract 7 e to the thirds away. We're going to be left with 14 e to the thirds plus the 7. We'll bring it along. It'll be part of our numerator as well. All right, so definite integral, doing integration by parts. Hopefully it made sense. I'm hoping the color coding really helps out as you're fitting everything in the correct places over there in the formula for integration by parts. Let me know what you think. Really hope it helps. Good luck.